Very good afternoon. This is Dr. Rajni Kamath, Associate Professor at Cyber. On behalf of Cyber, wishing you all warm welcome to this session. I am privileged to introduce speaker of today's session, Ms. Architect Pallavi Shinde, BIM Associate at GDC Bangalore. Ms. Shinde brings more than 13 years of experience in architectural design and working drawing production, space planning, facade developments, and landscape designing. BIM project management and upskilling staff in BIM methodology and Revit. She is an expert in BIM project lifecycle management. She is an authority in BIM project coordination, BIM project audits, BIM execution plan creation. Ms. Pallavi has worked on projects globally, including Middle East, UK, USA, and India. She has been instrumental with BIM implementations by successfully conducting BIM assessments. Madam has hands-on and team management experience in preparation of GFC drawings, bill of quantity extractions from Revit architecture and structure and MEP services. Ms. Shinde is a Revit certified professional, BIM lead verifier. She has completed MEP training and certification. Madam has participated in emerged leadership programs and studied and presented for customer interaction topic. Architect Pallavi Shinde has helped streamline processes like BIM competency mapping and developments, BIM standards creation to upgrade the skill set in BIM across organization. She also specializes in creating presentations on showcasing the awareness on niche subjects matters like LOD definitions, NAMIS work, 4D, 5D, and BIM execution plans. She has also involved in preparation of techno-commercial business proposals, project coordination, and served as lead auditor for project quality systems. So on this occasion, on behalf of Cyber and Atal Academy, we all welcome you for this online forum, Madam. So Madam will be delivering a talk on BIM for digital construction in this session. Welcome, Madam. Over to you, Madam.
Okay. Good afternoon, everybody, and thanks for giving me this BIM for digital construction. So just thought of initially I would like to introduce myself. I'm an architect with passed out from SPS MBHS College of Architecture. I'm from Kolhapur basically. So over to the topic about the BIM. BIM is the necessity of construction world today, and definitely when we are talking about BIM in this particular scenario, it is more on the digital side of the design. We are used to work more with paper. We are used to work more with AutoCAD. But beyond that also, we have so many things in this construction world which we have to witness, and we have to grow with all of this. So just starting with the presentation with this very brief talk. So just to elaborate more on the BIM side of experience, I can say it is a multidisciplinary approach when we are talking about BIM, and it's more into creation of virtual buildings or virtual structures which are far more uh, implemented or constructed on the system, on the computers before going on site. As it is a virtual construction, whatever issues we are going to face on site, we are going to actually understand them all well in advance when we are starting with the virtual construction on our systems itself. So we have multiple softwares which support BIM. BIM is, I'm going to come to the definitions, but there are multiple softwares like Revit, Naviswork, EcoSim, and all of this software support to create a multidisciplinary environment and to give us more of the coordinated model, which is far more clash free, we can say, in terms of when before going to the site, I can say. So this is just my brief introduction, and the current certification which ma'am has already explained you. So these are some of the snapshots of the projects which we have done for multiple locations like USA, Middle East, Hong Kong, Singapore. So what exactly is BIM? BIM, the full form of BIM is Building Information Modeling. What do you mean by 3D and BIM? I'm just going to start very basic because I can understand that few of you might be students, professionals who are very new to this particular topic. We are used to see the 3D approach or 3D models of the building, right? But we are, what is difference between 3D and BIM then? So the I, which is called as information, is the difference between the 3D model and the building information modeling model, I can say, a virtual model. So it is not only giving us a 3D visual, like when we are creating a 3D, it is also giving us better data quality. There will be no change orders. Now, whoever is aware of the contractor methodology, they must be aware of change orders, right? So we need to reduce on the change orders. Collaborative design, first of all, when multiple disciplines are coming into building, like architecture, structure, MEP services, landscape design, or any other heavy firefighting services. So in that case, we are witnessing so many clashes on site. So what used to happen so far? We used to witness those clashes on site, right? But here we are resolving those clashes when we are building this particular model virtually. So we are getting those clashes far more in advance and not on site. Collaborative design, no data loss, and virtual model, definitely we are going to get a virtual feel of the building, how the building is going to look when we are going to construct on site. Then prefabrication, fewer accidents on job site because of, as we are resolving a lot of issues more in advance. So that is going to give us fewer accidents. Then virtual simulations, definitely we can create a 4D simulation. I'm going to come to 4D later on in my presentation. Also coordinated approach, because as all the consultants are having the same set of model, they are much more coordinated. So they are not going to work like, okay, architect is working only on architecture, structural consultant is going to work only on structure. It's not going to happen in all of that case. So it is going to happen step by step. We are starting with architecture, but in the same model, we are going to put structural data. We are going to do modeling of MEP services and whatever disciplines are required. So an architect is also seeing MEP, an architect is also seeing structure, where it is clashing, and all of that more in advance before it goes on site. So this is how the BIM model works, and the BIM methodology. So what is exactly BIM to define it? Is it a software or is it a, I cannot say. BIM is not a software. First of all, there is a lot of people always say BIM is a software. No, BIM is not a software. BIM is a methodology which is giving us, which we are implementing via softwares like Revit or Ecosym, Bentley products as well as Autodesk products, to create this virtual BIM methodology. Okay, so BIM is a methodology, not a software. So I would like to briefly give you a definition of BIM. Okay, BIM, a building information model, is a digital representation of the physical and functional characteristics of the project. So it gives you both of the data. As I have already explained you, it is information which is more important into this model. Information in terms of, suppose we are constructing a wall, so we are going to get not only a 3D solid. When we are constructing a wall, we are also going to get the parametric properties of wall, like the material applied to the wall, the thickness of the wall, even if you want to give it a fire resistance property. All of that is the I, that is information which we are giving to that particular model. So because of that, it is called as a set of information and work collaboration tool. Now, this information can be viewed by multiple disciplines, multiple discipline consultants. It's not only that one discipline or one architect is viewing this data. So a shared database of the information. So in one model, all consultants can able to see this particular data. They can refer to this data at any point of time. This is a 3D CAD model, like how I was telling you that what is the difference between 3D model and BIM model. So 3D CAD model with added information. So information plays an important role. Hence, we are calling it as building information model. Then further, we can use this particular model not only till the stage of construction, but we can also use it for analysis purpose, like for green building design. If you want to do energy analysis, if you want to get into simulation, like on construction, you want to schedule it out that this particular activity is going to take this much time, and these are the dates. So all of these simulations also we can do after at the construction or site stages, I can say, on site, whatever stages we are going to follow, that also we can do with this particular model. Also, we can do facility management with this model. So suppose you have a hospital building or something like, a building which requires a maintenance year by year. So you can use this data to actually do a lot of facility management in future. So this model will be saved with the FM manager, and he can definitely churn out this data into multiple uses. He can put the expiry date of certain objects so that he will get a reminder. So all of that is facility management. So this is not limited to only 3D modeling and giving it on site. So it has multiple benefits after even execution. So coming to the history of evolution of the design, how we have started, and as I have briefly spoken about this, that we have started with paper. Okay, then we have started with electronic drafting, wherein we used to have knowledge of CAD, and still we are more with CAD, right? So later on, we have moved to the age of model. Now, when we have started with CAD, it was all 2D. Then we have moved to 3D modeling with 3ds Max software or SketchUp. Still, we are using it, right? And now, if whatever I'm talking is the age of integration. So we don't have to build just models. We have to integrate multiple discipline. That should be our approach to deliver a successful digital model on site, which is clash free and which is integrated. What do you mean by integrated modeling? Integrated means no discipline is getting clashed with other discipline. So there is a very good understanding virtually that we are resolving all these clashes more in advance before it goes on site. So because of that, it is age of integration. So this is the evolution, how we have been going through throughout this life cycle of the design. So coming to the problems inherent in traditional construction processes, what used to happen so far? And I guess most of you can agree with me that why we are facing so many clashes on site, or why we have to stop work on site. Because when architects start something with the design, he is working and his focus is more on architecture. Okay, then when structural consultant come into picture, his focus is more on structure. Step by step, if I want to take it to all other consultants, they are mostly focused on their own disciplines. So this is the approach which is coming on from the traditional, from the past, wherein we are focused more on our own disciplines. So this is the design team, this is the owner team, these are the construction teams which are on site. So we have multiple mail exchanges, we have multiple drawing exchanges between this, but all of the what I can say, all of the stakeholders. Okay, but what happens is, as we are mostly working with 2D drawings, or we are just building our own 3Ds for that specific discipline, and we are more into our own disciplines, there is a lot of coordination issues on the site. This may happen. Inability to fully coordinate the design because we are working mostly with CAD, or we are just overlapping and checking our drawings, which is not the ideal way. I can say still we can have some more clashes. Now MEP and rest of the consultants will come later into picture. They are not starting right from the start of the project because they need something finalized from architect as well as structural consultant. So they will get the last time in the design phase. So the inability to fully coordinate till the time we get into execution, it is, we cannot able to coordinate so much with the 2D methodology. So good ideas are also holded back and enter into the project too late because we are very much busy and focused into design, as well as this coordination, this issue management. Somewhere we may lose time and we will not have so much of time on all of these ideas. Then also the cost matters, right? So always we go with the cost part of it when it comes to any kind of construction. So we want to make our projects reasonable in cost. So all of this will have, owner is at risk to the contractor. If there are any design errors or anything, there will be a lot of transactional contracting, limit cooperation and innovation. So we basically, the summary is, we cannot able to fully coordinate because of all of this multiple activities going on. There can be multiple clashes which needs lot of discussion. Whereas I can tell you what are the best approach which the current construction industries are taking. So we have this BIM room meeting. Okay, so what does the BIM room meeting means? The one model is viewed by all the consultants sitting together in one room, and they are just discussing about this clashes, where what is going wrong between which discipline, and they are trying to resolve it then and there. So this BIM room meeting is organized on every maybe weekly basis, how complex the project is, it all depends upon that, or monthly basis. And then the report is generated on the clash detection work, where we can able to witness all the clashes, and the same is actually resolved in the model. Then the drawings are generated. Okay, so whatever, this is the methodology which is used to resolve most of the clashes right in the meeting room, then create the GFC which are clash free. Okay, so this is how we are tackling all the problems through, whatever we used to face earlier. We are tackling all of this problem in this particular way by using this digital methodologies. So, as I have briefly given you an introduction, but I would like to still compare, because there is so much to compare between what exactly do you mean by 2D drafting, which we are doing currently, and what is modeling in terms of BIM. I'm not saying only 3D modeling. What is the difference between 2D drafting and modeling? So I will just start step by step. Like, if suppose I will give you an example of AutoCAD versus Revit in this, so that whoever has that particular approach or have seen those particular softwares, they can able to easily resemble between these two workflows. So whenever we are drafting something in CAD, it is a 2D object, right? But whenever we are modeling something in softwares like Revit, it is a parametric object. What do you mean by parametric? Parametric means it defines a size, shape, volume of that particular object, which can be extracted as a bill of quantity. So we are not only modeling the models, but we can also able to extract the bill of quantity of that particular model very properly with the volumes, and also we can add a cost factor to it, which can give us all of the basics, means like we can get all the cost of the modeled objects. So we can easily extract wall quantities, door quantities, window quantities, which currently mostly we will do manually, right? To put it in the table when it comes to, with CAD, or giving it as an attributes or something like that. So here we have a very smart objects like tagging of the objects, which is also giving us a flexibility to number the door. So suppose one door has a size of 900 by 2100, and the same door is going 100 times. You don't have to do it 100 times actually. You are just modeling it one time, and the same object, as it is parametric, can be changed to a size of 1200 also. So here you are saving a lot of time. It's not like exploding a block and creating two lines there in CAD. It's not like that. It's like you are just stretching the object as it is parametric. You can able to edit all of the its particular parameters and give it a very clear picture. So revision management is also very much easy. Suppose today you have something which is 900 by 2100, it has got revised to 1200 by 2100. You don't have to waste time by drawing it again and again. You just have to duplicate the object and create a new type of that particular door. So because of having this capability in modeling parametric objects, we are actually saving a lot of time. Okay. Then whenever we are doing AutoCAD drawings, we have to create our own sections, our own elevations, and our own details, right? But here, when we are using softwares like Revit, one model can be cut vertically to create a section. One model can be created, can be seen through four sides as an elevation. One model can have an cutout or enlarged view of a certain corners or portions, whichever you want to detail it out as a details. So we can use only one model to create multiple views, three-dimensional views, sectional views, sections, 2D section, plan views, elevations, even the details out of it, which we will spend so much of time when we are doing it with drafting, or which we are doing it and we were unable to visualize it properly, because our sections, our elevations are, we have to visualize and we have to do. But if you want to make it little quicker, or you don't have to waste so much of time there, then this will give you a very quick results when you are modeling it at any stage of the construction. Now most of the time we do it like we have multiple stages in architecture, right? We have concept design, we have a detailed design stage later on. So in concept we can just work on the block model, then in detail design we can get into, you know, schematic design, we can get into little more details. Even the detailed design we can create all the GFCs. These are all the progressions. Now if you have knowledge of this kind of tools, you can make it very much faster. Your visualization is going to be utilized to create a very good creative model. Okay, because you are not wasting time in drafting, you are just wasting time in designing. So this is going to definitely help you out in having a better visualization, better presentation, to give it to your client or present it to your client very quickly, that okay, today morning you have sat, just designed something and created a block model and just shown it to client and got the approval, then gone into detail and you can detail it out later. So all of this can be managed. The presentation factor is also here, like we can also able to apply material here, so you can visualize most of the things more in advance, that how material is looking like, how your thicknesses of wall is going with the material. So all of this you're going to visualize far more right from the design stage. So your visualization is improved day by day, and your design is going to be when you are going to finalize everything, it is just going to be a final product which you must have designed somewhere in the first stage of the design. So all of this is what is the difference between modeling versus 2D drafting. Also, the two-dimensional printed documents becomes the quick and accurate byproduct of parametric design. Now, here we are not only doing modeling, but when the same model is cut horizontally, we can able to achieve all the plan views. So whatever we are doing in 2D, all of that is going to get, extracted right from the model. So suppose somewhere you have got a revision in one floor, the floor plan will get auto updated. We don't have to go and check for the floor plan again. So as my model is one, I'm going to cut it horizontally. If I'm shifting the wall, it gets shifted even in the floor plan, even in the detail, even in the elevation. So this is the correlation between different views. Hence, we call this approach or BIM as more coordinated approach. So we don't have to sit and coordinate. Okay, I have changed the plan. Now I need to go to section and change it. Now I need to go to detail and change it. And we are all humans, right? There is a chance we can do a manual error in that. So here it doesn't happen, because you are just changing a model and everything is getting updated, like all drawings, all details, all elevations. So this is going to save us a lot of our time. That. So definitely when it comes to stages of construction, how we are using BIM. Like, I have briefly already introduced you to certain, but you can just see is BIM, building information modeling, is applied at every stage of the construction as well as in the infrastructure project. Now, there was a misconception earlier that this will work only for buildings project. No, we are using this for infrastructure projects also, like tunnel modeling, then water projects like water plant models, wherein we have piping modeling as well as water treatment plants. The scale is huge, and I will tell you, when I'm working with now Hong Kong, Singapore, and multiple locations, they are all getting into automation, which is the latest stage of BIM. So right now we are just learning BIM or creating something in BIM, but they have, the later part of it is automation, how to, save more time with this particular methodology. So that is the current scenario or stage which is going on with BIM. So we have multiple stages of construction, and it can be used in multiple stages. So I can say, right from the surveying, you can do a cut fill quantities with even you can create a topo surface when it comes to surveying, reality capture. Even you can apply some roads, you can create roads, you can apply subterraneans or surveying basis on the surveying data. You can create the contours to understand the land more properly. Okay, then even you, then further it goes to planning, concept, and 3D designing, pre-construction stages. Okay, but we can start right from the land development. We can also extract cut fill quantities, like suppose you are cutting a pit on the site, or you are cutting the particular you require some site activities, site office, or you require some external services like external sewage system, external water systems. All of that can be first built on the site before, as a site office activities. Then you are getting into design, then you are getting into live buildings. So currently we have one water treatment plant from Singapore. So we have all of these cut fill quantities. The BIM execution plan is also set more in advance at this stage, wherein, which consultant is responsible for what is clearly mentioned contractually, and what are the different milestones of the submission. All of this is clearly mentioned in BIM execution plan. So to brief you, what is BIM execution plan? BIM execution planning is a document which is prepared before any critical BIM project starts. So that document states number of consultants who are going to work with this project. That document also states the milestones, the usage of software, which software you are going to use for this particular project. Then even the data flow, like who will stop, like suppose an architect is starting the design, then what is his cutoff date or milestone to give it to another consultant, or all the data flow is mentioned in that. And also some plus minus things, like we can exclude this quantities, we can give you this quantity. The LOD of the project, LOD is level of development. So what will be the LOD of the project at which the project is awarded? It can be LOD 100, it can be LOD 200, it can be LOD 300. So I'm not going to explain LOD in this particular presentation, but I'm just going to give you an overview. So we have multiple things which needs to be set contractually between all the consultants, that what exactly is expected out of each and every consultant before creating this particular BIM model. And that document is called as BIM execution plan. So BIM execution plan is also a stage of digital construction. That is the first stage. Before starting anything else, you are going to build, prepare that particular BIM execution plan, and that is the whole and sole responsibility of the BIM manager. So we have this new role because of this particular digital construction methodology. We have got this new role in the industry, which is called as BIM manager. I joined AECOM as a BIM manager 4 years ago. So it is more to do with all of this, to manage the project, to manage the life cycle of the project. We need to have all the info more in advance and all the discussion more in advance before starting with any project. It cannot be 100%, but at least to draft it in a more particular way, that no confusion will create later on in any project life cycle. Okay, so we have different stages of construction which supports this. Okay, so even the stages of construction and the ownership of those stages are clearly mentioned in that particular document. So we can go for setting out, site layout, then site works, earthwork and grading. Then we have utilities, which are external utilities on the site, which can be built by multiple BIM softwares like Civil 3D and all of this. Then we have construction software like Revit. We can build it. We have some Bentley tools called EcoSim that also can be used. Then we have construction validation softwares, which are used for multiple validations, even applying what where, even the clash detection software which can detect clashes before going to site. Then connecting with the infrastructure, facility management, which comes later on, wherein we are applying all the stakes, all those facilities. Then completion and handover, which will also come as a last stage. So these are all different construction stages, and BIM can support all of the stages in the life cycle of the project. So different dimensions in BIM, as I told you, I am going to talk very briefly about all of the stages and dimensions. So these are all the dimensions which are very much used to and which we use on daily basis when we are working on BIM projects. So 3D is known by everybody. Okay, 3D can be also laser scanning. So suppose we have a building, we have to create an as-built model of a building, and the drawings are missing for that building, or it has been hand drawn long back. So by the use of laser scanning, all the images, 3D laser scans are generated, and then the 3D model, which is a virtual model, is developed by stitching all those images. That is also, a part of 3D. That is also one of the project requirements which we will get mostly. So all of this animations, visual effects, or only visualizations, that can be also called as 3D. So which we are aware of. What do you mean by 3D? And then we have 4D. So what do you mean by 4D? When the 3D model is getting attached to the time factor, that is called as 4D. So the fourth dimension is time scheduling. So we have multiple 4D simulator tools which can actually schedule it out for the stages of the construction. So suppose I have a pile to start with first. Okay, so I will attach a date, a time, a day, I can say, on site activity basis. So we always have a primavera schedule, or project managers of the project can create, step by step activity schedules on site. So that site activities are getting linked with the time factor to each and every object. So suppose the pile construction is going to be a first stage of construction, and it is going to start on so and so date, and it is going to end on so and so date. So we can attach the time factor to this particular construction stage. So that is called as 4D. And not only for one stage, we can attach it for multiple stages. Like we have multiple story building getting onto it. So we have this set of activities on site. We can attach the time factor to it, which is called as scheduling. So this is also we can create a simulation with this, which can give us an idea that are we really on the schedule, or are we ahead of the schedule, or are we behind the schedule? Because now the construction world is more with, what is the schedule of the project. We cannot do years and years one building, right? So what can be the start date, what can be the end date? So the project managers are responsible to create these schedules and simulate it by attaching time factor to the 3D model. Okay, so that is 4D. We have multiple tools like Naviswork, 4D simulations, which can be used for to create this 4D scheduling. And we can get very good clarity on the project. Every month, we can review the progress of the project with respect to what was the planned date for this activity and what is the actual date for this particular activity. We can actually track the project. Then what do you mean by 5D? 5D means you are adding cost to the model. So whenever we are creating a time, whenever we are attaching time, we can also attach cost factor. So suppose you are having certain numbers of piles, certain number of walls, it can actually be linked with the cost of that particular volume. And we can also generate the 5D estimation with respect to that model. So that is called as 5D estimation. So that also can be done by multiple softwares, like mostly we have done it with Naviswork or all of these softwares. Then we have 60, which is like energy analysis or detail energy analysis. We have softwares like Ecotech. In Revit also we can do energy analysis. We have multiple softwares which can track the daylight analysis, which can track, the directions, the placement of the building with respect to the sun directions, and getting, a good internal environment, adjusting it more at the stage of the design. So this is called as 60. What do you mean by 70? It is a facility management, which I have already briefly told you. The life cycle of the BIM strategies, BIM as built, the model has got built now. Now you need to maintain this particular building year and year. So how you will do this? This will not be applied to any residential mostly, but it will get applied to the complex buildings like hospital structures or hospital buildings and all of this. So all of this is covered under 7D. Okay, so these are the different dimensions which we contractually agree with the clients, that okay, I need 4D and 5D with this project. I need 4D, 5D, 60, 7D to be done for this particular project. So these are all, clauses before starting with any BIM project. That what is the expectation out of this project. As I've already spoken about the clash-free models, so it reduce a lot of construction rework and material wastage, stopping work on the site. We have multiple software again, like we have Naviswork, we have some internal interface check in Revit, as well as some of the other 3D BIM softwares. So that can be also checked with respect to, hard clash, soft clash, 4D workflow clash. Suppose the MEP equipment is going on and you have a very good architectural design structure coming in there, then who will take a call? who is the consultant who will take a call on this. So both the consultants have to sit and take a point wherein, once the decision is taken ki who will change, then the same is going to get updated in the model, which will resolve that particular clash. Okay, so clash free models are a need of today's digital construction, I can say, because we need to save money, we need to save our time on site, we need to be fast in our decisions, which at some point of time, if the clashes are coming on live site, it will also, what I can say, it will also spoil our aesthetics, because we have to break something, we have to take 11th hour decisions which can look ugly on site. So all of this is going to help us to build a very good digital construction models, or digital construction buildings on the site, which are more clash free. So clash free models are really, really, really a big requirement of today's digital construction. We all are doing BIM, or the BIM methodology is only meant to create coordinated set of models and drawings. So clash free model is the need. So this is one of the most important step in BIM methodology, that what exactly is our goal by doing BIM, or by following BIM methodology. Our goal is to create the clash free models. That is our goal. So benefits of BIM in terms of, as we have step by step seen all the benefits, definitions, and even the purpose why we are using it. I cannot say that BIM is mostly used for simple structures, but BIM is mostly used for complex structures, I can say, where you have critical shapes, critical disciplines coming into the picture in terms of firefighting services, sewage treatment plants, or internal firefighting, plumbing services, MEP services, multi-storied building, all of this to better manage complex projects by combining data of various file sizes and formats into single view. So one model will help us to simplify lot of complexities of the building, because if you start doing multi-storied building with a very much 2D tool, you may arise or face a lot of problems on site. So complex buildings like water treatment plant, multi-storied apartments, and uh, industrial buildings or something like that can be better managed with this tool, because you will end up save a lot of time, and the data is more managed in one location. Now centralized file system, I would like to talk about this also. In BIM we are centrally placing the file. Because of that, the multiple disciplines are working on the same model. They are not creating their own discipline model. They are creating discipline models, but the place where we are saving this model is one location. So because of that, we coordinate the model, and complex building structure requires this coordination right from the start of the project. So we can achieve that very easily with BIM tools. Then project visualization, definitely. Sometimes what we have seen is when we have created a 3D building, okay, when we are creating 3D models only, not with BIM. So the on site, the building is completely changed because of so many changes throughout the design process. But when we are creating a virtual building model with BIM and the visualization, most of the design is frozen at multiple stages. So the visualization also is frozen, and it's not like something we have given on site and something has got constructed. So there are no any surprises that it was looking like this earlier when we have frozen the design, but on site we have faced so many issues and my visualization has completely changed. So it's not like that. So the project visualization is more accurate, and the developments can be updated in the model as soon as the call is taken. Suppose we are changing something, the model get changes, as well as even the visualization has been changed at the same time. So we don't have to do a multiple effect like create a new 3D now and create new renders and visualization. That's not required. It will give you a very accurate visualization. Then when it comes to construction execution, we are as we are doing 4D scheduling, as I told you, that we are actually attaching time to the 3D model. So it is actually giving us a clarity at after a month where I am. Okay, a project manager can easily evaluate that am I going ahead of the schedule or am I dragged back, and what are the factors which are dragging me back, where exactly I'm delaying, in which activity I'm delaying. So all of the activities, as it is listed more in advance by the project manager or by taking concurrence from all the consultants, they are actually tracking on each and every activity and each and every schedule very properly. So because of that, construction execution also can be tracked, monitored. If we are delaying, we can take a call more in advance. It should not be like 1 year is done and then we are discussing about why we have delayed. It's not like that. It's like the activity, as soon as the activity is getting delayed, the same is discussed, resolved, and your further plan dates are revised. So maybe your plan date was 1 month before, but now you are actually talking to all the consultants and saying because of so and so factor, this has got delayed, and my schedule is changing now. My dates are changing, and you revise the complete 4D scheduling more frequently, and the models are also getting updated accordingly. So you have more reliable schedules, I can say. It's not like you don't know anything about the construction progression. You are well aware that, okay, if I have planned this building to be completed within a year, because of XYZ factor, I'm taking another 2 months. I'm aware more in advance, not on the last stage of the year or last completion of the year. I'm saying, okay, I think I need 2 more months to finish this project. So it's not like that. You are tracking it more frequently. Cost reliability. Why can we say it as cost reliability now? Because we are modeling it to the scale accurately. We are putting all the material property in the model, and we are also putting cost for that particular volume. We can able to attach the 5D as well to this particular model. So because of that, the cost reliability is very much accurate. Why? Because we know the exact volumes which we have modeled. Okay, so suppose I have modeled a wall or I have modeled a column, I have modeled a beam. It is just not going to be a 3D object like just a square. It has some dimensions to it. Like suppose beam is there 400 by 400, 400 by 600. I am going to get an accurate volume of that particular beam object, which is going to help me to attach a cost factor and get a very proper cost estimate to it. So my cost estimate is not going to be a lump sum. It is going to be actual because my sizes of each and every building components are accurate. Okay, it's not a 3D that we are just modeling a square as to show it as a beam, or a square to just make 3D square as a column. It's not like that. We are actually attaching the dimensions to each and every model components. So because of that, the volume will automatically get multiplied to the cost per square meter or per square feet, whatever the cost is. And the bill of quantity is much more accurate than uh, means like than our traditional lump sum methodologies. So all of this is going to give us a very good solution when we are building complex objects, when complex buildings, when we want accurate project visualization. Then we have construction execution, which is in place because we are knowing what will come now, what will come next, and are we on schedule, are we are not, as well as cost reliability, because we know each and every volume, we know each and every dimension of objects. So just having a cost in place as per the standards can give us a very accurate bill of quantity. Okay, so in short, if we can see here, BIM has 3D visualization, scope clarification. We can get even marketing presentations. We can have virtual mockups. Okay. You can also do a walkthrough inside your building once the building is built. So we can also do something like walkthroughs, fly-throughs, because we have clarity on site now. We have clarity where exactly the building is getting placed on site as a 3D visualization, because we know all the contours, topo surface data, the placement of the building. Okay, so our walkthroughs are more realistic. It's not like we are just putting some plants and creating some walkthroughs just for visualization. Coordination between services and drawings as well, because critical services are like, for critical services, it's not enough to only create 2D drawings. It requires a lot of coordination for MEP services, plumbing services, firefighting, all of the water hydrants, all the multiple services which we are using. So coordination between multiple services is very much important. And then not only coordinated model, but coordinated drawings as well, which are going to go on site as a coordinated output. So avoidance of discrepancy, yeah. Suppose something comes on site or some issue comes on site, we have to stop the work, we have to go there, we have to attend. Workers' labor cost is going to get affected because we are stopping the work to take a call on certain things. So this avoidance of the discrepancies is like, once you have submitted everything to site, you are peaceful. You don't have to struggle with lot of issues on daily basis, because you have each and every corner's clarity. As you have model in front of you, you can just guide all the site people by looking at the model. Okay, so these are all benefits of BIM in very brief manner. Now the difference. What is the major difference between our traditional construction methodology approach and integrated methodology approach or process which we are dealing with in nowadays world? What is the difference? Previously, we used to work hand on hand, like one consultant to other consultants, and we were not having more clarity on what exactly is going to happen in MEP, what exactly is going to happen in that service, all of that. No. Now, as we are working integrated, as we are working on one single model for one single project, everybody is integrated. They can see, look at MEP. At the same time, they can look at structure. They can look at multiple services to take a call more in advance. So this will help definitely uh, into giving a very good output, which is coordinated. So it will also improve on most of the time what happens, the consultants have intermediate uh, misunderstandings because of all of these issues. So that can be also resolved because we are looking at model far from the start of the design. So mutual respect, collaborative, we can create some innovative we can take some innovative calls in the project as we are far more stabilized on the clashes or the other issues. We are much more sorted, so we can take some innovative call that okay, in this project we can introduce something new in this way. So early involvements and even the early goal definitions for all the consultants. So all of this will definitely change our complete way of looking towards the construction process methodology while constructing any complex building structures. How to start with, what is the right approach, what are the documentation to start with, like BIM execution plan, how to design, how to visualize, how to coordinate between multiple disciplines. And this is definitely going to get benefited when we have this multiple I can say technologies coming into picture to create this integrated methodology. Okay, so this was the major difference between the traditional processes and integrated approach or processes which we are dealing with in the current scenario. I have just prepared some snapshots of some of the data exchange, or just to give you an idea. This is not a big one, but how exactly a complex project of BIM looks like and how the data exchange look like. Okay, so most important thing is the data or the models are stored in common data environment. So mostly, suppose we are starting with any project with uh, what exactly we will do? We will save our files in local system, right? And everybody has their own set of files. We don't have anything like common data environment. With BIM project, it is mandatory to have a common data environment, which is going to place all our models centrally, and the models are getting accessed from the central server and not from the local server. Then everybody will have their own models, right? So that is not a correct approach when we are actually dealing with BIM process, BIM project workflows. So most important thing is common data environment, where and what common data environment we are going to use. So there are multiple common data environments like project wise. It is with Bentley. We have BIM 360 with Autodesk, okay, which can also allow us to save heavy file, which is cloud based, which can allow us to save a heavy file or heavy model file, and multiple consultants can approach the same central model. So central file is very much important in this process. Then we have these tools like Open Plant is one software, EcoSim is one software. For clash detection, we are using Naviswork. Now, this is the example of one Bentley related project, but we may have multiple softwares like Revit can be there. Then it all depends upon the project required. Then we have all of these softwares are residing in one common data environment space. which is giving us, multiple discipline output. Now we have even cell libraries or block libraries, which can be used to create this model, which are like parametric blocks. Like example, I can say I need a different kind of window which is not in my library, standard library. Then we have to create that parametric object as a cell library. So all of this is getting stored centrally, and all the discipline consultants have to approach the central location only to get into it and create it. Then finally, once the federated model, what do you mean by federated? It's an integrated model is built, then we can go for clash detection, that is with Naviswork Manage, which can give us multiple discipline clashes. Like suppose I need to run a clash check for architecture versus structure discipline, then I can definitely run a clash test for two models only, not a complete whole model. And it can give me a major clashes that, okay, architecture is getting clashed with structure in this area. Then I can able to generate the report of the clash detection, and then that report can be shared with the coordination team, or we have to resolve it with the client or with the different consultants, whoever is responsible for that clash, and update the model, so that if suppose first time we are doing a clash detection, we have some 5,000 clashes. Next time, when you are updating those in the model, your clashes should reduce to, might be 1,500 or nil. It all depends upon how big the exercise is, because complex building will have complex clashes. So which are the major clashes, which are the minor clashes which you can ignore? Sometimes it shows a clash with door and wall also, so that clashes you can ignore by giving a bigger tolerance. So all of this will give you a clash free model, but for that you have to follow this complete BIM data exchange methodology. Now this is just one example. Every project has its own BIM data exchange because the softwares are changing. Now my CD, like common data environment, for suppose this particular project is project wise, but for other project it is BIM 360. So BIM 360 use all the Autodesk softwares. So then the ecosystem will get replaced with Revit and any other Autodesk platform softwares. So this data exchange will change project by project, and we have to create this data exchange more in advance when we are deciding on the softwares, deciding on the project design more in advance. At that point of time only the project client, like the affordability, cost wise, which softwares will go, the client requires this particular software. So all of that is finalized far more in advance at the time when we are writing the BIM execution plan. Okay, so we have to understand the process by taking consideration of all of this software. And what is our ultimate goal? Our ultimate goal is clash free model, or our ultimate goal is just visualization. Our ultimate goal is coordination between XYZ disciplines. All of that is far more set more in advance by understanding the client requirements, and then accordingly choosing the software which can be cost effective for the client, because as you know we have to use all licensed softwares when we are working on this kind of project. We cannot use any software without any licenses. So we need to have for all the project team all licensed software. So who will purchase the license? Who will bear the cost? All of that we have to agree on contractually at the time of BIM execution plan. So I just wanted to show you one BIM data exchange flow chart. So this is how we start. This is how we understand that how the data is going to flow between multiple softwares, and what is the ultimate goal. So some of the snapshot which I have extracted, sorry, I cannot specify anywhere the name of the project, hence I have removed all the names. But this is just to give you an idea that how the 2D looks like, how the 3D looks like, okay, in the projects. And the same is extracted. Like if you can see, I have this tunnel model in gray color, which is a complete tunnel model for the airport structure. The same tunnel model, when we are looking in, even uh, this is a 3D part of it. It has multiple services which are running through. It has all airport related services which is coming into the picture. Okay, so we have structure, which is a tunnel structure. We have services, tunnel related services like lightning, like even the MEP services which are running through the tunnel. Above side, if you can see, there is one structure which is getting developed as a structural model. This is a structural shell, and below, if you can see the plan view of the uh, uh, little longer structure of the same above structure. So we have these tools to create all of this kind of structure, and we can use different multiple software formats to give the shape form, to create plan, to create 3D views out of the same. To and in one sheet, why I have taken this sheet composition here is, in one sheet you can also place plan with 3D views, with even the sectional views. And all of this can be compiled with a proper 2D annotation, 2D dimensions, and wherever you are cutting the section tags, and the title blocks, notes, all of that. Okay, so it's just like how you use the tool, like how we are already creating some 2D AutoCAD drawings. In the same way, we can generate all of these drawings from this softwares. Also, if you can see below, this is a water treatment plant, which we are currently working on. This is a very huge project going to run for around 5.5 years from Singapore. And it has multiple services and structures into it. So this is just a 3D view of that particular building. So why I'm showing you all of this is just to show you how the look and feel of the digital documentation looks like. It is same with, you can compile 3D, you can compile 2D onto the same sheets, and you can view the model more in advance virtually, and describe issues, study model. Like my role most of the time in this kind of project is to review, audit the models, where exactly what is lagging, what is missing. Then we have specific standards which are related to specific countries. So looking at the standards, we have to build the model as well as the drawings, having different naming convention, then having different color coding to the specific, and even the naming of file, folder, drawing is all specific, that is all defined. And BIMCAD graphic standard. So what should look like what, which color to use, which model solid geometry can reflect what standards. So all of that is a part of a BIM project delivery, which is applied both for the 2D as well as 3D documentation. So all of this will lead you to a successful BIM project life cycle. If you understand that right from the start, how the project starts from BIM execution plan, how the model is developed at LODs, different LODs, and how to start with concept, how to then go to schematic, detailed design, then also apply the annotations to it like object properties, then extract bill of quantities wherever you require, the quantities of the object, then also to present your sheets properly after coordinating properly with all the disciplines, giving the presentations on like creating the GFC drawings, then creating the visualization like building model, and giving it to different views, different angle walkthroughs that can be developed means with the same model. Then you can also give some part detailing or part modeling, like a structural modeling, suppose discipline specific modeling, or whatever, however you want to support the site, you can cut through and you can definitely give them that respective data. So this is like a complete workflow which I have shown you, that how BIM is helpful and responsible to deliver a digital construction models in nowadays era, in this particular era, I can say. So I would like to have a Q&A. If anybody has any questions on my presentation or questions on BIM, then definitely I would like to take some of them.
Yeah.
Good afternoon, ma'am.
Yeah, good afternoon.
Yeah, this is Mulli here.
Yeah.
I have a question regarding a simulation model.
Yeah.
Normally we have ecotech and other stuff to analyze indoor sunlight penetration.
Yes.
Do we have any software, simulation software to analyze outdoor sunlight simulation?
Outdoor, I have done that with Revit mostly. Revit also is one of them. And energy analysis, there are current softwares. Ecotech is supporting mostly internal as well as external energy simulations as well. So yeah, in that way, we have done it with Revit also, external.
For one of my research,
Mhm.
so I need to simulate the reflected sunlight in
Mhm.
outdoor environment.
Mhm.
So how do I go about it, ma'am?
Yeah, you need to have right tools like Ecotech is there. Ecotech, you try it out. Even the Revit part, it will also give you an external energy analysis.
Okay, thank you, ma'am.
Yeah, thanks. Any more questions?
Yeah, madam, there are two questions in the chat box. I'll read
Okay.
for you. Yeah,
Yeah.
just a second. Just
Yeah.
a second. Yeah. Mr. Shailesh is asking,
Mm.
let me read it for you, madam.
Yeah.
There might be different software or portals might be used.
Mm.
However, to utilize for the best results, there might be uniformly of data required. Is
Mm.
there any system or code for that? Example, from the surveys data to designers data to planning to facility manager.
Mm. Means a same set of softwares.
Yeah, yes.
Okay. So I would like to say every project has a different requirement. We cannot standardize softwares, means like we can just go with this softwares. It's not like that. And there are no any standards to use software. It all depend upon your client requirements, your which software will give you which output. Like Suppose if you want to go with Revit, it has its own set of outputs. So whenever you are starting with any project, it's not anything standard. You have to, or the client, depending upon his cost factor, will decide on all the lists of softwares, and we have to work through it. Several times we face lot of limitations, like some softwares will not give us, the required output. But then also we have to work with interoperability. What do you mean by interoperability? Sometimes we get the data from, say I need data from Revit and I need to get it into ecosim software. So this is called as interoperability. Through IFC we can achieve it, but we cannot really say that we can go with only this set of softwares for facility management, this is the one, or for construction surveying, this is the one. We cannot standardize that. It all depends upon the different factors and different condition, the project type, all of that. Yeah.
Yeah, thank you, madam.
Thank you.
One more question from Mr. Vijay.
Yeah.
Any online training program for more knowledge and certification related to BIM?
There are several programs which are taken up by Autodesk, or taken up by Bentley Systems for this. But what I suggest is, like, whoever is working on this practical projects, if you are taking training from them, like practical project environment and practical, because they know more on the tool base. Like most of the time we'll get software trainings, but those are tool based. But if you really want to understand the project life cycle, then definitely you have to learn from a person who is practically witnessing it on day-to-day basis. But yeah, there are programs which are conducted by multiple universities also, as well as Autodesk, Bentley are the software providers. So they also have launched these portals on them. But live practical exposure, definitely you have to take it from somebody who is dealing with the projects on day-to-day basis.
Yeah. One last question, madam. Mr.
Yeah.
Jitesh is asking about updated software version of BIM modeling.
Okay, so we have different, means like latest versions of softwares which are going on, like 2020, or if you talk about Bentley, it will go Select Series 6, which is the latest one. So it all depends upon which license version you are using. But every year the upgrade will happen for all of this software, and we cannot downgrade those softwares. Means like, suppose you are working on any project and you have upgraded the project to say 2020 version, that is this year version, then you cannot able to take that model back or save as that model to the lower version. So this is the facility, or this is, I can say, a drawback which we have from the software companies, because they want us to use the latest versions and latest subscriptions. So because of that, upgrade needs to be very much careful, and it requires even the client or the cost concurrence, how much it will cost you for your project. But yeah, every year all the softwares will get upgraded.
Yeah. Yes,
Yeah.
madam. Yes. Thank you very much. Very interesting and informative session. Madam, you took us to a domain, digital construction domain, and various features of BIM integration, the dimensions of BIM. You explained us elaborated structural elements of BIM, the benefits of BIM in a very interesting way. Definitely, it is useful for the participants present in this particular forum. On behalf of Atal Academy, Cyber organizing team. Thank you very much, madam.
Thank you. Thanks for giving me this opportunity and giving me this dais to help upgrade our students and our professionals' knowledge. Definitely, we require a lot of this because we need to know all of these latest technologies and delivery platforms in the digital construction. So, thanks a lot for
Yes,
everybody.
yes. Thank you, madam.
Thank you.
Yeah, you can sign out.
Yeah. Okay.
Yes.
Hello, team. We'll be having the next session as usual in the given timing. We are supposed to join at 2:15. We'll be having a lunch break. Thank you.